This is Algebra 2, Chapter 1, Section 6, in which we will be solving compound and also absolute value inequalities. So we need to know what these things are before we can solve them. Compound inequalities are just two inequalities or more, but typically two, that are joined together by either and or or. The idea behind these kinds of problems is to solve each part separately and then graph them onto the same number line. So let's start with our very first one, which is a good place to start in general. 8 is less than 3y minus 7, which is less than or equal to 23. You can see two different inequalities going on here. Let's split them into two separate things. We have 8 less than 3y minus 7, and also 3y minus 7 is less than or equal to 23. When they give you a jammed together compound inequality like this, it's always and. The middle stuff goes with both parts. Well, from here we can solve. I like to have my variable on the left, so I'm going to move it over to the left first to make life easier later. Subtract the 8 over, divide by negative 3, so I had to flip the sign. I've got one part of the problem done. The other part, just add the 7 over, divide by 3, and we have y is greater than 5, and y is less than negative 10. When it says and, we're looking for where the two solution sets agree, where they overlap. Well, numbers greater than 5 start at 5 and go to the right. Numbers less than 10 start at 10 and go to the left. Things that fit both descriptions are between 5 and 10. So just this strip between the two values. Not filled in on the 5 because it wasn't equal to, but it is filled in on the 10. So your number lines now will have two numbers on them because you have two parts of your solution. So let's pause here and you try this one, come back, check your results. Negative 12 is less than or equal to 4x plus 8, which is less than or equal to 32. Split into two problems. Move my variable to the left in the first case so that things are simpler. And we end up with x is greater than or equal negative 5 after we flip that sign. And x is greater than or less than or equal 6. Numbers greater than negative 5 and also less than 6, again, that's the strip in between. Okay. Now there's an OR problem. K plus 6 is less than negative 4, or 3k minus 1 is greater than 14. Okay. The first one's easy to solve. Subtract the 6. The second one, we have to go through a couple of steps. We have to add the 1, and then divide by 3, k less than negative 10, or k greater than or equal to 5. When the problem is OR, anything that works for either solution is good. Anything less than negative 10 is good. Anything greater than or equal to 5 is also good. They don't need to overlap in an OR problem, and typically they won't. Your basic garden variety OR problem is going to have the two arrows pointing away from each other. So again, let's pause here and you try this one out. Come back, check your answer. A little division on both cases. In the second one, we had to flip the sign because it was dividing by -3. Filled in both circles because it's equal to, and again, they point opposite directions, which is what we expected. So that's compound inequalities. Oh, sure, it doesn't show up on the whole screen. Well, we can fix that. When we have absolute value inequalities, those really are compound inequalities again. We have to go back to a variation on the Stuff-Blah theorem. Okay, remember, Stuff-Blah was stuff is equal to blah and stuff is equal to negative blah. In inequality form, if our sign is a less than, then it's stuff less than blah and stuff greater than negative blah. If our sign is greater than, then it's an or. And we could replace it with the or equal to versions. Less than or equal to instead of less than. Now, something to note in both cases, when you do the negative blah part of it, the sign flips from what it started as. We were less than, it turns into greater than. We were greater than, it turns into less than. Less than is always an and. Greater than is always an or when you have absolute value inequalities. And just like with the absolute value equations, you're going to have two solutions to deal with. You're going to split it into two problems and get two answers, and then combine it, put it together on a graph. The only time you have to get two answers is when it's two problems to start with, or absolute value inequalities. So we'll do a couple of these here. Absolute value of x is greater than 2. We'll start with the simple case, take it apart. X is greater than 2, or x is less than -2. They're both solved already. It's an or, we expect it to point away from each other, and they do. Numbers greater than 2 and numbers less than -2. Suppose we have this, absolute value of x is less than 3. Well, we split that apart. Since it's less than, it's going to be an and problem. X less than 3 and x greater than -3. When we see and, we expect it to overlap because we need answers that fit both descriptions. Numbers smaller than 3 and also greater than -3 are in between. Okay, let's step up a notch. This time we have absolute of 4x plus 5 is greater than 7. That we need to split into two problems. Since it's greater than, I expect an or here. 4x plus 5 is greater than 7, or 4x plus 5 less than -7. Subtract the 5 over, divide by 4. Subtract the 5 over, divide by 4. I'm looking for numbers that are either greater than a half or numbers that are less than -3. It's an or, we expect it to point apart, and it does. So 6y minus 5 absolute value is less than or equal to 13. Okay. We have to split that into two problems. It's less than, so we should have an and here, and we do. 6y minus 5 less than or equal to 13, and 6y minus 5 greater than or equal to negative 13. Add 5, divide by 6, add 5, divide by 6. It's an and, we expect it to overlap, and it does. Numbers less than 3 and also bigger than negative 4/3. Negative 1 1/3 if you're a mixed number fan. One last thing we have to look at, there's a couple of special cases, again, that they like to mix in, especially with absolute value. If you have absolute value of stuff and it's greater than a negative number, then it's no, that's backward, should be less than. There, it says less than, really. If absolute value of stuff is less than a negative number, then there's no solution. Because remember, this thing over here is positive. Positive less than a negative number. There's no solution for that. And your graph would just look like an empty number line. Put some number down here to show that it's a number line, that you didn't just leave something blank. But there's nothing to graph. And again, I have my sign backward. If the absolute value of stuff is greater than a negative number, then it's all real numbers. Remember, this is positive. So a positive thing is bigger than something negative. Yep, it sure is. So you would have a completely filled in, shaded everywhere number line. And again, put a number there to show that it's a number line and not just a line out of nowhere. And again, we can replace the inequalities with the or equal to versions and it still works. So a lot of stuff here. We have to split our inequalities into two problems, work them separately, and then graph together. We expect and graphs to overlap each other. We expect or graphs to point away from each other. And remember your stuff and your blah when you split that apart into the two problems. And watch out for those special cases at the end. And as always, if you had questions, I hope you wrote those down. Bring them in with you, and we will see you in class.